Hello, this video explains the details of the electrical circuits. Before going to see the details, circuits elements should be known. Circuits elements are classified into two categories, active elements and passive elements. The elements which can deliver energy are called active element. The elements which consume energy either by absorbing or storing are called passive elements. The active elements are voltage source and current source. If the magnitude of the voltage or current source does not change with time, then the source is called as direct current source, or in short DC source. However, the magnitude of DC source changes with respect to the power supplied by them to the passive elements, that is loads. The symbols for the DC source are displayed. The sources in which its magnitude sinusoidally varies with the time are called sinusoidal sources. The magnitude of such sources will undergo cyclic changes, and the number of cycles per second is called frequency, denoted by F. The symbols are shown in the display. Simply we can say AC source. The passive elements are resistors, inductors and capacitors. An electric circuit means it consists of resistors, inductors, capacitors, voltage sources and or current sources connected in a particular combination shown in the display. When the sources are removed from the circuit, then it is called network, as shown in the display. The sources are further classified into two categories, independent and dependent sources. If the magnitude of a source in a circuit does not depend on voltage or current in any part of the circuit, then the source is called as independent source. Otherwise, the magnitude of the source depends on the voltage or current in some part of the same circuit, then the source is called as dependent source. The symbols are displayed. Passive elements. Resistance of a resistor may be defined as that property of a substance which opposes the flow of electrons through it. The practical unit of resistance is ohm. The resistance is represented by a symbol R of a conductor or a wire is directly proportional to its length L and inversely proportional to its area of cross section A. Resistance R is directly proportional to L by A, can be represented by R equal to rho L by A, where rho is a constant which is depending on the nature of the material and called as the specific resistivity of the material of the conductor. The specific resistance is defined as the resistance between opposite faces of a unit cube of the material. The unit is ohm meter. The reciprocal of resistance R is called as conductance and represented by G, which is equal to 1 over R. It is defined as the inducement offered by the conductor to the flow of electrons and is measured in Siemens, but the unit of conductance was mhos. 1 Siemens equal to 1 mho. Since R is equal to rho L by A, G is equal to 1 over R, therefore G is equal to sigma A by L, where sigma is 1 over rho. Sigma is known as specific conductance or conductivity of material. The unit of conductivity is Siemens per meter. The conductivity is defined as the conductance between the two opposite faces of a unit cube. A conductor or a wire is wound in air with some turns called as a coil or inductor. Since it is wound in air, called as air core coil. If the wire is wound on iron, then it is iron core coil. Wound on ferrite means it is ferrite core coil. Electric current passes through it, produces magnetic flux around it as shown in the figure. The inductance of an inductor informs how much of flux lines are produced per unit current I. The inductance is represented by L, which is equal to phi by I, where phi is Weber. 1 Weber equal to 10 power 8 lines. The unit for inductance is Henry. 1 ampere is passing through it, produces 1 Weber of flux. Then the inductance is 1 Henry. Inductor stores electrical energy in magnetic field. Capacitor. A capacitor is consisting of two metal plates which are separated by an insulator. Insulator is called as dielectric media. If it is separated in air, it is called air capacitor. If the ceramic is used as dielectric media, it is called as ceramic capacitor. If mica means mica capacitor. DC voltage is applied across a capacitor. Charges are stored in the plates as shown in the display. The capacitance of a capacitor informs how much of charge Q is stored per unit voltage. The capacitance is represented by C equal to Q by V, where Q is the charges in coulombs. V is the voltage in volts applied across it. The unit for C is farad. A capacitor stores 1 coulomb of charge. When 1 volt is applied across it, then the capacitance is 1 farad. Capacitor stores electrical energy in electrostatic field. The resistance, inductance and capacitance are called fundamental parameters of the electric circuits. Practically, these parameters will be distributed in nature. As an example, consider the resistance, inductance and capacitance of a transmission line which will exist throughout its length as shown in the display. But for circuit analysis, the parameters are considered as lumped parameters as shown in the display. In electric circuits, node means meeting point of two or more elements. Principal node means meeting point of more than two elements. Branch, the path between any two nodes. Closed path, a path starts at a node and travels through some part of the circuit and arrives at the same node without crossing a node more than once. Series connection, if two or more elements are connected such that this current through them is the same, then the connection is called series connection. Parallel connection, if two or more elements are connected such that the voltage across them is same, then the connection is called parallel connection. Star connection, if three elements meet at a node, then the three elements are said to be in star connection or T connection. Delta connection, if three elements form a closed path, then they are said to be in delta connection or pi connection. This video is dedicated to Dr. K. Nagappan, who taught this subject in networks. Request to subscribe my channel, post comments, mark like and share videos. Thank you.